Assalamu alaikum students, hope you all are fine, and today's topic is all about states, movement and structures. Okay, grade 9 chemistry. Let's start with this topic. Yes. Table of content. In part 1 we are going to learn about the structures of different states. In part 2 we are going to learn about movement of particles and experiments. As you already know that we have done with part 1, but we will do some revision of it. Okay, we will do revision. We have done with this topic already. In part 2 we will start a new topic that is really easy. In part 3, past papers and quiz. Okay, as usual. Let's move on. Structures of states. All you need is focus and practice. I think you all already know that we have learned this topic, but in this topic we will memorize the structures. Okay, we will see how the structures look like of solid, how the structures look like of liquid, how the structures look like of gas. So nothing you need to that nothing is very hard, just you need focus and practice. Okay, yes. Structures of states. Here are some structures that you need to memorize by yourself. First of all, you have only 3 structures. You need to memorize these 3 structures. Okay, they are really easy. Okay, first structure is solid. In solid, the particles you can see are tightly packed and arranged. Can you see any particle that is you can say they have space between them? No, they don't have any space because they are joined together. They don't have any space. That's why there is a specialty of solid. Okay, in liquid we will see yes, the solid key point is the solid particles are tightly packed, and yes, you can write this tightly packed. Okay, yes, the particles can vibrate. The particles will vibrate. Okay, in liquid the particles are loosely packed. What are they? Loosely packed. And there is a movement, and the particles are loosely packed, and they are free to, not that much free, but they are real. You can say, yes, you can say that they are free to move. Okay, but you cannot write that they are far apart. This is wrong for liquid. Okay, yes. In gas we will see the particles are very far apart. Can you see this much space is there? They are really far apart. That's why we will say they are far apart, and they are not joined together, right? Yes. Okay, done with this theory? Yes, these 3 you need to memorize. Yes, students, I will send you guys. Okay, so students, I am moving on now. I think no need for extra practice because we have done with this topic. Okay, yes, understood with the structures? Okay. Which state's structure is it? Okay, now I will ask some questions because this topic we have already done. Okay, so I think that you no need to memorize it again. Okay, yes. Which state structure is it? Please tell me. Okay, well done. It's solid. How solid? Because the particles are tightly packed and arranged. And ice is an example of what? Solid. Correct. Ice is the example of what? Solid. Always remember, whenever it comes in the exam, ice is the example of solid. Okay, yes. I'm moving on. Done? Okay. Identify the states of matter. In this, can you see that the way of asking is different? In previous one they asked state, and in this one they are asking identify. So the basic reason is to confuse the kids. Don't confuse in it. They are just trying to confuse you so they can test your knowledge. Okay, don't confuse in these type of things. Okay, yes. Okay, now tell me the answer. Okay, the answer for this is liquid. Okay, yes, the arrow is not on orange, the arrow is on the liquid juice. So yes, that's why it is liquid. Moving on. Name the state of matter below. Please tell me this. Really easy. The easiest one maybe. Gas. Well done. Gas. Moving on. I'm not explaining you each and every question right now because you already know that we have done with this first topic, so no need for extra explanation, right? Okay. Part 2. Now we will start a new topic. Okay, yes. Identify the process. In this topic we will identify each and every process This is also a really easy topic if you yes, if you will be focused in the class. Very really easy. We will learn first there will be ice, it will turns to liquid, and the liquid turns to this steam gas. This all we will learn in this topic. Okay, yes, let's move on. Different changing states. Okay, now please attention over here. Different changing states. Okay, changing, the word states mean that they are asking of states. Okay, different changing states. Over here we will start with solid. What we will start with? Solid, of course, solid. Yes, can you see the particles are again arranged in proper lattice, whatever keyword, but the basic keyword you can say is arranged tightly packed. Okay, so these particles are arranged like tightly packed. Okay, the particles are arranged tightly packed. So in this ice, can you you just need to memorize, whenever solid ice turns into a liquid, you already know that whenever you put ice in room temperature for 2 to 3 minutes, it will turn into a liquid. You already know this, right? So same happens over here. Solid turns to liquid, this ice turns to liquid, and this liquid, when this process is causing solid to liquid, so it will always called what? Melting. What is it always called? Melting. Whenever you have a ice, it will turns to a liquid. Okay, when it's at room temperature outside, yes, it will turn to liquid, and when it will turn to liquid, this process is called what? Melting. And when it forms a liquid, the liquid forms a gas. Okay, when we for example, I have a pan over here and I heat some thing in this I heat some water in it, and then it evaporates. Where is my I heat something over here and it evaporates. Okay, evaporates means some gas comes out. So this is called evaporation. What is this called? Evaporation. Whenever liquid turns to gas, what is this called? Evaporation. What is this called again? Evaporation. Whenever solid turns to liquid, what is this called? Melting. Whenever liquid turns to gas, what is this called? Evaporation. And you must need to memorize, whenever solid turns to gas, it is always called sublimation. What is this called? Sublimation. No, you don't need to memorize this. Just sublimation, evaporation, and melting. Now let's do the opposite. Whenever we are moving from gas to liquid, what? Gas to liquid. This is a very common example. You have a cold drink, you put it into the freezer. When you take out the cold drink bag, okay, you take out the cold drink bag, so the cold drink it converts into some drops, okay, so that is called condensation. It is a big example of condensation. Whenever gas turns into liquid, it is called condensation. And whenever liquid turns to solid, whenever you have ice, you have some water and you put it in the mold of ice, okay, and put it in the freezer for 24 hours, so you will see the result that it forms a solid ice like this. This process is called what? Freezing. When we move from solid to liquid, what is this process called? Melting. Whenever we move from liquid to gas, what is this process called? Evaporation. Whenever we move from solid to gas, what is this process called? Sublimation. Whenever we move from gas to liquid, what is this called? Evaporation. Whenever we move from liquid to solid, what is this called? Freezing. Understood? Okay. Liquid to solid. Now you guys have to answer me these type of questions. Okay, liquid to solid. Okay, whenever we move from liquid to solid, this is an example. Tell me the answer. Okay, I'm giving you 1 minute. So guys, 1 minute has already been over. Tell me the answer now. Yes, it is melting. Yes, it is. The correct answer over here is melting. Okay, so the correct answer over here is what? Melting. Okay, the correct answer over here is what? Melting. Okay, so kids, the correct answer over here is what? Melting. Okay, this is the correct answer I am submitting. The correct answer is melting. Okay, this is the correct answer. Let's move on. Name the state below. Okay, now you have to name the state below. Okay, this is the same. This is the question that you must answer it. I'm giving you 1 minute for this. Answer the question. Whenever we move from liquid to gas, what is this? Yes. Okay. Whenever we move from liquid to gas, it is called boiling. Yes. It is a general question. This liquid to gas is a general question for you guys. Okay. Whenever you have a pan, where is my drawing? We have a pan. We boil some water and steams come out. It is called evaporation. I know, but also the boiling word can be used. Okay. Boiling word also can be used. Okay. The correct answer is boiling. Okay. This process is called freezing. The correct answer is freezing. Let's move on. Okay, here we have to type the answer. Okay, I am typing. First, tell me, if you have to tell me, whenever we move from solid to liquid, what is this process called? Yes. Whenever we move from solid to liquid, what is this process called? Melting. The correct answer over here is melting. Okay, the correct answer is melting, because whenever ice changes the state, this is a good example when ice changes the state to liquid. Okay, water. Let's move on. Whenever liquid changes to gas, what is this process called? Evaporation, also we can call it evaporation. Both answers are correct, but the most you can also write evaporation, and you can also write boiling. Okay, both answers are correct for this. Boiling. Move on. Now this is part 3, kids. Okay, in this part 3 we will just learn how to we will learn some, you can say, movement of particles means some experiments. Okay, some movement of particles, you can say some experiments that are related to this topic, that are related to the movement of particles. Okay, let's move on. Yes, here also you need practice and focus, please. Movement of particles. First of all, we are going to learn what is when I am showing you. First of all, we are going to learn what is diffusion. What are we going to learn? What is diffusion? What are we going to learn? What is diffusion? Okay, kids, this is a really easy topic. We are going to learn diffusion. Okay, diffusion. In diffusion, what is diffusion? Please read this. Diffusion is the movement of particles from area to high concentration, where there are many particles, to an area low concentration. Where there are fewer particles, this happens due to random motion of particles. Diffusion can occur in both liquid and gas. Okay, you must remember this, that diffusion can occur in what? Liquid and gas, both states. Okay, no, it cannot occur in solid. Okay, yes. Now I'm not explaining you this diffusion. Okay, I will explain you in the next video, because I have already explained you. Still, if you want explanation, you can watch the recording of the next topic. Okay, this is the first experiment of potassium and magnesium water. Okay, so over here, for what we have to do first. Okay, I am showing you. Take a beaker of water and place some potassium magnate crystals at the bottom. Okay, this is the first step. You must memorize. The second step is that, can you see the second step is that the purple color slowly spreads out in the beaker. Eventually, the entire beaker turns purple. This shows diffusion in liquid, as the particles of potassium magnate spread among water particles. Okay, I know that some students don't know this experiment, and we will learn we will see the experiment in further. Okay, now I have just the basic concept is to tell you the experiment of the first experiment. This, I know that the steps you are not understand, I will explain you in further. See, kids, for kids who can understand. Okay, see over here. Potassium magnate water. Potassium magnate great for experiment because of bright color. Because of what? Bright color. If you take a beaker of water and place some potassium magnate at the bottom, the purple color slowly spread out. What are they trying to say? That if you take a beaker, you know what is a beaker? Yes, a beaker. This is called a beaker. This is called a beaker. Okay. Yes. In a beaker, you pour some water. For example, this is the beaker. Remove this. For example, you have a beaker, you put some water over here, and the water, and then you put some potassium magnate solution. Potassium magnate this solution. Can you see the purple solution? This, yes. You pour some of this, okay, and then it slowly spread out. What is this? It slowly spread out. Slowly what? Spread out. It slowly spread out to fill the beaker. See, first it is like this, then like this, then like this. There are 3 steps. Okay. Now this chemistry is in action. The particles of potassium magnate are diffusing among the particles of water. Means, see, the particles both are mixing. See, when we put the potassium magnate into the water, can you see that it doesn't stay in the same place? See this, when we have a clean pure water, we put some of that, it is a bit not mixed. When after some time, when you mix it fully, can you see how the solution look like? Yes, so it is mixed fully. Okay, and did you understand the experiment? Yes. Now see over here, it's the random motion of particles liquid to see in the previous page. This causes the purple color to eventually be evenly spread out. They are just trying to say the same thing that I have explained you in the upper part, that first of all we take a beaker, we pour some water, and this is a magnate potassium that we put it. Okay, then after some time the mixture is like this. After we mix it, it converts to this. Okay, they are just trying to say this. Okay, yes. Potassium magnate solution can be diluted by adding water. Okay, yes. Add more water to the final purple solution. This potassium magnate particles would spread out even further apart. They are just trying to explain you that when you put the potassium magnate, it when you mix, so the particles move further apart. Okay, yes, and the solution will be purple. Okay, yes. Yeah, here is a basic point for you all guys. See over here, potassium magnate and particles would spread out further apart and the solution would less purple. This is called dilution. Diluted or dilution, whatever you like to say. So they are just trying to say how this dilution occurs, what is this cause, and what we basically called it. Understood? The students understood? Yes. See, they are showing you when the particles are more far apart, even more far apart, then what happens? The more darker purple colors changes to this much light. See, can you see it? This process is called what? Dilution. Okay, dilution. I'm writing for you guys. Then this process is called dilution. Dilution. Let's move on. Understood? Okay. This is the second experiment of what? Experiment 3, ammonia and hydrogen chloride. Ammonia and hydrogen chloride. You don't need to see the this part because this is explanatory. Until or unless you will not understand with the experiment fully, you cannot understand this. Okay, understood with the experiment? Experiment is all about ammonia and hydrogen chloride. Okay, yes. What is the experiment all about? Ammonia and hydrogen chloride. Okay, yes. Let's move on. This is the experiment. Can you guys see over here? What cotton wool soaked in ammonium solution. First of all, we will take this, you can say, this big liner tube. Okay, in this tube what you will do, in can you see this cotton? This cotton is of cotton wool in soaked in ammonium solution. In what solution? Ammonium solution. Cotton wool, you know this cotton wool? Yes, cotton wool is soaked in ammonium solution in the, yes, left side, in the left side. In right side, this cotton is cotton wool soaked in which? Hydrochloric acid. First is soaked in ammonium solution, next is soaked in hydrochloric acid. Okay, hydrochloric acid. Okay, now see over here. Now this NH3, I will tell you what is this. NH3 is ammonia. What is this? Ammonia. Ammonia solution. Okay, I'm writing NH3, ammonium solution. So they write the, basically, you know, short form, so that's why they write the real names in from the periodic table. Yes. Now HCl is what? Hydrochloric acid. HCl. Okay, HCl. Okay, now what are they trying to say? That the product, now what happens when these all, first of all, you know, when these both cottons are soaked together, there is a lid. Okay, there is a lid. Lid means you already know. Okay, lid, there is a lid. Okay, and when you remove the lid, all the gases, these both soaked cotton, you know, mix, you can say that their gases mix together, and what they form finally? This I'm writing over here, NH4Cl2. They form NH4Cl2 to the HCl end of the tube. Can you see that here? Can you see that this cotton, this last cotton, can you see the hydrochloric acid cotton? This cotton is producing very less what? Air. And can you see this ammonia one? Ammonia is forming very, see, this much ammonia has formed, and this much only what formed? Yes, a hydrochloric acid. Understood? This experiment is just to show you that the both ammonium and hydrochloric acid reaction. Yes, let's move on. Bromine gas and air. Okay, in this experiment you just have to show you that in this experiment there is lid. For example, this example, that there is a lid. There is a what? Lid. We don't remove the lid. There is a lid. Okay, and in this container, this is a whole container, but of course when there is a lid, then there are two different portions. In first portion there is air. What? Air. In second portion there is bromine gas. What is this? Bromine gas. So this bromine gas over here is filled with what color? Brown color. Understood? So now this is before. Okay, before, when we are not starting the experiment, this is the before structure. When we open the lid, see, the lid is here. When we remove the lid or open the lid, see what happens over here. See, this is when we remove the lid. See what happens when we remove the lid. All the air and bromine gas mix together and form this color. This color, you can say peach color. Yes, peach color or light brown color, whatever. But this experiment is showing whenever air and bromine gas mix together, this form this formed what? A light brown or peach color. Okay, yes, we will learn these right now. I'm just giving you the introduction of these experiments. We are not learning them in details. In next topic, inshallah, we will learn them. Okay, yes. Movement of particles, MCQs. Now you have to answer me these MCQs. I am giving you 1 minute. Okay, yes. Now students, see over here, diffusion occurs because what? I told you in the beginning. Diffusion occurs when what? Particles move randomly in all directions. When we have NH3, for example, we have chloride, okay, and aluminum. For example, we have these both chemicals, and when we mix them, what is formed? Diffusion. And this diffusion definition is what? Particles move randomly in all directions. This is one definition for it. Okay, please tell me the next question answer. Which of these following is an example of diffusion in gas? Tell me. Ink spreading in water, perfume smell spreading in room, and what? Please tell me. Yes, I will explain these questions in the next lecture, inshallah. Yes, the correct answer is C. Well done. MCQs of movement of particles again. Okay, Brownian motion can be seen by observing. Students, please don't answer this question. This question is a bit mistake. Please over here. Please don't answer. I will explain you what is the. I will explain you because until now we haven't do this experiment, so that's why maybe yes we haven't do the experiment of this. So leave it for now. Tell me the answer of this. Diffusion happens faster in what? Tell me. So over here you can even choose the option gases or liquid, because we have learned that both can both happens faster, but the most you know correct answer can be gas, because gas has more space. Particles are more far apart, so the correct answer can be gas also. Yeah, the correct answer is gas. You can also write liquid. Yes, solid is totally incorrect. Yes, let's move on. These are the correct answers. Please check your answers. First answer, second answer, third answer, fourth answer. Okay, leave the fourth one because we haven't done this. Okay, let's move on. Arrange the states of matter. Okay, in this question, just arrange the states of matter. Okay, tell me which state will come first, which state will come second, which state will come third. Okay, yes. First, it will solid, always solid. Solid because ice, then melt what? Form liquid. Liquid, and then it forms what? Gas. Well done. Let's move on. I hope that the time has already been up. Now please, this is a refreshment for you all guys. You do answer it. Understood with this topic? If yes, then select your mood. Yes, feeling good. Yes, feeling happy. Nothing. Please tell me. Any answer can be correct. Yes, but the most commonly I choose is this. My choice is yes, feeling good. Okay, let's choose this one. So students, I have choose this, by the way. Okay, students, I have choose this, and what about you? Okay, you can choose this. Nothing. Okay, let's move on, kids. I hope that you all enjoyed in this topic. Yes, this topic is a bit boring. The last experiment one, I know some experiments are a bit boring, but I will try my best to inshallah make these experiments more encouraging for you all guys, so it will be more easier and better way to learn. Okay, yes. Okay, Allah Hafiz everyone. Today we have to learn this much only, so we have done with this with our topic. Allah Hafiz everyone. I will see you in all in our next lecture, inshallah. In the next lecture is really easy also. I know that this topic is a bit the last experiments are a bit boring, but I will try my best to make them also encouraging for you. Okay, inshallah ta'ala. Okay, Allah Hafiz everyone.